Have you ever stared up at the night sky and wondered, what secrets lie hidden in those glimmering points of light? What if I told you there are cosmic wonders we could never see with our own eyes, mysteries so far away they seem almost impossible to grasp? But there is a way to uncover them. Imagine a machine, a giant floating eye, orbiting high above Earth, peering deeper into the universe than ever thought possible. Welcome to the fascinating world of space telescopes. In this video, we'll explore how these extraordinary instruments, like the Hubble Space Telescope and its successor, the James Webb Space Telescope, are reshaping our understanding of the cosmos. But first, let's answer a burning question. How do they work? Ever wondered what's up there that we can't see? I'm Umbra, and I'll reveal it all. Keep watching. To understand the brilliance of space telescopes, we need to look at their origins. For centuries, astronomers relied on ground-based telescopes. These machines magnified the heavens, revealing countless stars and galaxies. But there was a problem: Earth's atmosphere. The air around us, while life-sustaining, is also a blur-inducing, light-scattering obstacle. It causes the stars to twinkle and limits the clarity of celestial images. Think of it like trying to peer through a frosted window pane. No matter how powerful the telescope, ground-based observatories are at the mercy of weather conditions and atmospheric distortions. Enter the concept of a space telescope. By placing a telescope outside Earth's atmosphere, scientists could get an unfiltered, crystal-clear view of the universe. It was an ambitious idea that would change astronomy forever. The Hubble Space Telescope, launched in 1990, was humanity's first step into this new frontier. Named after astronomer Edwin Hubble, this telescope was designed to orbit Earth at an altitude of about 340 miles, far above the distorting effects of the atmosphere. But how does it work? At its core, Hubble is a reflecting telescope. It uses a giant mirror, 2.4 meters across, to collect light from distant objects. When light enters the telescope, it bounces off this mirror and is focused onto smaller mirrors, which direct it into scientific instruments. These instruments include cameras and spectrographs that analyze the light, breaking it down into its individual wavelengths to reveal the composition, temperature, and motion of celestial objects. But Hubble doesn't just rely on optics. It's equipped with advanced gyroscopes to maintain its orientation and solar panels to power its systems. Engineers communicate with Hubble via radio signals, sending commands and receiving data. Remarkably, Hubble completes a full orbit of Earth every 97 minutes, taking breathtaking images along the way. Yet, Hubble's journey hasn't been without challenges. Shortly after its launch, scientists discovered a flaw in its primary mirror. The telescope's images were blurry, a devastating setback for NASA. However, engineers devised a brilliant fix: a corrective optics system like a pair of glasses for the telescope. After a space shuttle servicing mission, Hubble began delivering the stunning, high-resolution images we know today. Hubble's discoveries are nothing short of revolutionary. It captured the iconic pillars of creation in the Eagle Nebula, revealed the accelerating expansion of the universe, and provided a deeper understanding of black holes. It even allowed scientists to estimate the age of the universe, 13.8 billion years. But Hubble's success wasn't just about the science. It captured the public's imagination. Its images, vibrant and awe-inspiring, brought the universe closer to humanity. For the first time, people could see the majesty of space in unparalleled detail. Hubble wasn't just a telescope. It was a time machine, a storyteller, and a symbol of human ingenuity. As groundbreaking as Hubble was, scientists wanted more. They envisioned a telescope that could look even deeper into the universe, back to the earliest galaxies formed after the Big Bang. Enter the James Webb Space Telescope, JWST, launched in December 2021. But Webb isn't just a bigger, better Hubble, it's an entirely different beast. For starters, Webb operates in the infrared spectrum. Unlike Hubble, which primarily observes visible and ultraviolet light, Webb's instruments are designed to detect infrared light, essentially heat radiation. Why is this important? Because the most distant galaxies are also the oldest, and their light has been stretched into the infrared by the universe's expansion. To see them, a telescope needs to be sensitive to these wavelengths. Webb's design reflects this mission. Its primary mirror is a massive 6.5 meters in diameter, made of 18 hexagonal segments coated in gold to enhance infrared reflectivity. This mirror collects faint light from billions of light years away and directs it to Webb's scientific instruments. But operating in the infrared poses unique challenges. Any heat from the telescope itself could interfere with its observations. To solve this, Webb is equipped with a 5-layer sun shield the size of a tennis court. This shield blocks heat from the sun, Earth, and Moon, keeping the telescope's instruments at an icy 233 degrees Celsius. Unlike Hubble, which orbits Earth, Webb operates much farther away, about 1.5 million kilometers from our planet at a location called the second Lagrange Point, L2. Here, the gravitational forces of Earth and the Sun balance the telescope's motion, allowing it to stay in a stable position with minimal fuel use. Webb's journey to L2 was an engineering marvel. After its launch, the telescope underwent a complex, weeks-long process of unfolding. Its mirrors, sun shield, and other components were meticulously deployed in space, a feat compared to origami on a cosmic scale. Any misstep could have doomed the mission, but Webb's deployment was flawless. So, what has Webb discovered? Even in its first year of operation, the telescope has delivered jaw-dropping results. It captured the deepest infrared image of the universe ever seen, revealing thousands of galaxies in a single frame. It studied exoplanet atmospheres, detecting water vapor and other molecules that could hint at habitability. And it observed stellar nurseries, where new stars are born, shedding light on the life cycle of stars. Webb's infrared vision also allows it to peer through cosmic dust, unveiling hidden regions of space that Hubble could never see. From distant quasars to the faint glow of the earliest galaxies, Webb is rewriting our understanding of the universe's history. Imagine for a moment the oldest light in the universe, the faint afterglow of the Big Bang itself. This light, called the cosmic microwave background, has been stretched into infrared wavelengths over billions of years. Webb can detect these faint signals, helping scientists piece together the story of how the first galaxies formed, how they evolved, and how they paved the way for the stars and planets we see today. This is more than just science. It's a journey into our own origins, a quest to understand how everything we know came to be. How do Hubble and Webb's instruments turn light into knowledge? It all comes down to spectroscopy. When light passes through a prism or diffraction grating, it splits into a spectrum of colors. By analyzing this spectrum, scientists can determine an object's composition, temperature, velocity, and more. For example, Webb's near-infrared spectrograph, NIR-SPEC, can analyze the light from multiple galaxies simultaneously, a massive leap in efficiency. These instruments are paired with cameras that capture stunning images. Hubble's Wide Field Camera 3 and Webb's Near-Infrared Camera, NIR-CAM, are just two examples of the cutting-edge technology behind their discoveries. Yet let's not forget the human effort that goes into these missions. Operating a space telescope isn't easy. Hubble required multiple servicing missions to repair and upgrade its systems. Webb, on the other hand, is too far away for repairs. Engineers had to ensure every component would work perfectly from the start, a daunting challenge. Then there's the issue of data. Both telescopes generate enormous amounts of information which must be transmitted back to Earth. This requires powerful communication systems and international collaboration. Teams of scientists and engineers work tirelessly to analyze the data, turning raw numbers into groundbreaking discoveries. Why invest so much effort into studying the universe? The answer lies in our innate curiosity. Space telescopes like Hubble and Webb help us answer fundamental questions. How did the universe begin? Are we alone? What is the fate of the cosmos? Their discoveries also have practical applications. The technologies developed for these telescopes have led to advancements in medicine, communication, and even climate monitoring. Moreover, they inspire us, reminding us of humanity's potential to achieve the extraordinary. Think of the images that have come from these telescopes. A single photograph of a distant galaxy cluster can contain thousands of galaxies, each holding billions of stars. It's a humbling reminder of how vast the universe truly is and how small we are within it. Yet, it's also a testament to our ability to understand and explore it. These telescopes don't just show us the universe, they show us what we're capable of when we work together, dream big, and reach for the stars. As we marvel at the achievements of Hubble and Webb, it's worth pondering what comes next. If you've enjoyed this exploration of the cosmos, consider liking this video and sharing it with fellow space enthusiasts. Together, we can inspire curiosity about the universe and support the pursuit of knowledge. Scientists are already planning future telescopes like the Nancy Grace Roman Space Telescope, which will focus on dark energy and exoplanets. These instruments promise to push the boundaries of discovery even further. Hubble and Webb are more than just machines. They are symbols of human ingenuity, curiosity, and our unyielding desire to explore. As they continue to reveal the universe's secrets, one thing is certain: the story of space telescopes has only just begun.